There is currently an epidemic in Central America. Thousands of young men harvesting sugarcane in hot conditions are developing kidney disease because they are dehydrated. In some communities, a half of all men have kidney disease. But this is part of a much bigger global public health problem. In Australia, far fewer people develop kidney disease because they're dehydrated. But still, 1 in 10 people have the disease. 1 in 10. It's high, right? Well, unfortunately, this figure is twice as high for Aboriginal Australians. Perhaps the most devastating thing in these people is that kidney disease does not just affect your kidneys. It causes high blood pressure. And high blood pressure harms just about every other vital organ and can be deadly. So why do people with kidney disease get high blood pressure? One way is because the way the brain talks to the blood vessels changes. Instead of gently whispering to the blood vessels, the brain now shouts at the blood vessels. Did that raise your blood pressure? In my PhD, I want to know what changes in the brain in kidney disease for it to cause high blood pressure. In my experiments, I've been using sophisticated neuroscience techniques to listen to the messages that the brain sends the blood vessels in rats with kidney disease. By deciphering these messages, I have discovered that high blood pressure is caused by too much brain activity in an area of the brain called the hypothalamus, shown in red here. Brain cells in this area that are normally fairly quiet suddenly become very talkative in kidney disease. But people with kidney disease can't simply walk into their doctor's office and ask for their brain cells to be turned down. So in my research, I wanted to know exactly what bodily process is making these brain cells become too talkative, because it might be possible to stop this process instead. What I found is that a chemical message originating from the diseased kidneys is telling these brain cells to increase blood pressure. But how is this kidney chemical speaking to these brain cells? What molecular language does it use? If I can understand this language in my research, then in the future it may be possible to develop new therapies to stop high blood pressure from developing in people with kidney disease. And such an important development would mean that for the sugarcane harvesters in Central America and for our Aboriginal Australians, being diagnosed with kidney disease is not necessarily a death sentence. Thank you for your attention.